Hey guys, so this is an example of a limiting reactant problem. This is the balanced equation written out. It calls for 3 aluminum metal in addition to 3 ammonium perchlorate, which results in aluminum oxide, aluminum chloride, nitrogen oxide, and water. So the first thing we need to do is figure out which reactant is the limiting reactant. So first, we're going to do aluminum. So the problem states that there are 7 grams of aluminum in the mixture. So we need to convert this into moles. So we have 1 mole over 26.982 grams, and the 26.982 grams is simply from the periodic table, so that equals 0.259 moles of aluminum. So now we need to find how many moles of ammonium perchlorate there are. So I'm just going to write AP. So the problem states that there are 9.32 grams in the mixture, and we need to multiply that by 1 mole over 117.488 grams, which is the molar mass, and that equals 0.0793 moles. So to find the limiting reactant, you would see which number is smaller when it's broken up into the amount with the coefficient in front. However, for this problem, you don't need to do the dividing method because both coefficients are the same, and it is obvious that the aluminum molar count is significantly higher than that of the ammonium perchlorate. So we know that the limiting reactant is ammonium perchlorate because this is smaller than this. And you have to remember that the overall test is not just the molar amount, but the molar amount divided by the coefficient of that reactant. We just don't have to do it for this one because the coefficients are the same. So, with the limiting reactant established, we can now answer the rest of the questions. So the first question asks, what is the theoretical yield of aluminum oxide? So the theoretical yield is what it should turn out in an experiment as if all the conditions are perfect. So we just do this mathematically. We know that we have 0.0793 moles of aluminum perchlorate, and we need to use the mole ratio to get this for aluminum oxide. So we know that for every 3 moles of aluminum perchlorate, there is 1 mole of aluminum oxide. Sorry, A2O3. So now we have it in moles, and we need to convert it into grams. So for every mole of aluminum oxide, there are 101.961 grams. And this is just the molar mass, which is adding up all the numbers with the AMUs provided on the periodic table. So this equals 2.70 because of sig figs grams of aluminum oxide. Now the next problem asks to find what is the percent yield if an experiment has 1.56 grams of aluminum oxide as the result. So what we're going to do is we're going to put 1.56, which is the experimental yield, over the theoretical yield, which is 2.70, and you multiply it by 100. So the percent yield is 57.8%. Lastly, the problem is asking how much of the excess reactant is left unused. So now we need to go back to the reactant. So we know that we have 0.793 moles of aluminum perchlorate, and you use the mole ratio. So we know that for every 3 moles of aluminum perchlorate, there are 3 moles of aluminum. And now we need to convert this into grams. So for every mole of aluminum, there are 26.982 grams, and that equals 2.14 grams of aluminum. Now this number is the amount used. This is not your answer for excess. To find excess, we have to take the total, which is 7.00, and subtract the amount used, 2.14, from it, and that equals 4.86 grams are left unreacted. So that is how you do a limiting reactant problem. So right now I am on my 4th video. If you have any questions on the material, please feel free to post it in the comment section, or if you would like a video made about any of the other sections or information, please also put it in the comments. Thank you.